This is a talk about cognition. How do we think? How do we think under pressure, like I am right now, and like you're all going to be when you do the lightning talk karaoke shortly. So the starting point here is you do not know how your own thoughts work. This is the model from a very well-known safety scientist called Jens Rasmussen. He studied power plant operators during the largely 60s, 70s, 80s. He's really influential. So this model is really influential. So the idea here is that your lowest level of behavior is skills. This is stuff that you do pretty much automatically. Like for those of you who are blessed with being able to write a regex, you can automatically write a regex. Anyone? The next level up is rules. So this is where you can recognize a situation that you have seen something like it before, or you know something about it, and then you can choose the right run book to follow. I think that's the closest analogy in our world. So some well-known situation. Then when you run out of rules, when you're in a situation where the rules do not seem to apply, you have to resort to knowledge, to your mental models to do something sensible. Okay, so you actually have to think here, right? Now, is this the full and complete situation? Not really. So after Rasmussen, there comes a man called Gary Klein, who's also been very influential in the field of cognition. He studied firefighters initially, but then he branched out and studied all sorts of other things like medics and even housewives. This is his model. It's a bit more complex than Rasmussen's. The most interesting part here is you've still got a recognition to see what aspects of this situation is similar to what I've seen before, what are the relevant cues. And then you use mental simulation. So this is his model really of what experts do. Experts hardly make decisions at all. They kind of just say, I kind of just take the situation in, I recognize things, and they will choose a decision without it seeming like a decision. They just sort of know. And that's one of these ways in which we don't have this privileged access to our cognition, because if you ask people who are expert in something why they made a decision, they'll say, it was just obvious, I didn't even make a decision. But this aspect of mental simulation is really important. This is how we decide whether or not an action is appropriate, will it work? So we sort of go through this loop of saying, will this work, will it have bad side effects? And you'll modify something until you get to something that seems reasonable. There are limits on mental simulation. We can do about 3 moving parts, and we can do about 6 steps of a process. And after that, our brain just goes, no, doesn't work. But if you're an expert, you can cheat. You can chunk things together and do more. You can process more information because you can see patterns in the signals that you get. There's a guy called Dorner who calls this super signals. So you can take more information in because you can see the patterns in the information. Something else that experts can do is metacognition. You can think about how you think. So think about the context of a software incident. You might recognize that you have misdiagnosed something and you're going down the garden path, or you don't have the evidence. So takeaways. Plans are nothing, planning is everything, because it lets you do that simulation in advance. And then you don't have to do it when you're under the time pressure. This is really important. This is really, really, really helpful in cognition. The other big takeaway is focus on how the systems work. The rules are easy. The rules are there. The rules are not that helpful. What really matters when you have to come and deal with something novel and stressful is how well you understand that understand the system, how good your simulation ability is. Here are some references from the talk: Rasmussen, Klein, also Jean Flack. These are sort of some of the giants in the field. This is what I'm working on for my master's dissertation at the moment. Thank you for listening to this lightning talk.
Put your hands together for Laura Nolan, and thank her for speaking about how we think and making me think about how much I want some Irish takeaway now. All right.
Hello, everyone. So firmware is software, and it provides a low-level control of device-specific hardware. And it's a combination of platform-specific or something that's hardware-specific and platform-agnostic. And that's a snapshot of a general-purpose server from an open compute. And some top examples that everyone might be familiar with is like BIOS or UEFI. BMC, or baseboard management controller, which is what I would like to talk about a little bit more, the SSD, firmware, etc. So what is manageability? It is a set of features that enable ease of use of the system, how easy it is to configure, deploy, modify, and supervise the system. And server class systems usually have something called as a baseboard management controller. And on the top left is the dedicated embedded system, which is BMC on ASPEED's AST2500 SoC. And it shows a snapshot of how an Intel server could be managed. And it provides remote management capabilities to the server. And the firmware software stack, of course, the foundation is the hardware. On top of that, you have a bootloader, example U-boot. And then recently, most systems have moved to using Linux instead of, say, maybe proprietary RTOS like VxWorks. And then you have the applications. Manageability also has this concept of in-band versus out-of-band. In-band means the system should already be in a good working state. So it kind of defeats the purpose slightly because you're already expecting the system to be healthy. Out-of-band is where it provides a lot of value. And some of the things you can do through out-of-band is like remotely power on, off, reboot the system, change the network settings, reinstall the firmware on that, and apply the latest security vulnerabilities, patches, etc. And you can also do remote diagnostics and recovery of the system. Like you can get hardware configuration, and the manageability features provide a great deal of help in being able to manage systems at scale. It's a big aid for troubleshooting as well. And what goes into making this happen? A lot of people, a lot of work with the electrical engineers, system designers, architects, study of a lot of schematics, data sheets, understanding what requirements have to be realized in the firmware and what features really make it manageable. And servers have been there for so long. Is something really changing? Typically, the BMC used to be part of the motherboard. Now there is a change to move these components into a specialized board called the DCSCM, or Data Center Ready Secure Control Module, a snapshot of which is there. And some of the challenges in manageability firmware, it's a resource-constrained environment. It's a small embedded system, and there's a lot of ask to manage a whole lot of systems with this firmware. And it can also be the source of some security hacks, so it's important to do it right. And day-to-day life as a firmware engineer is a lot of code reading, troubleshooting, debugging, and handling on-calls, collaboration with a whole lot of other team members. And yes, did I say troubleshooting? I have to say that again. Skills as firmware engineer. Yes, the good old C is still one of the very preferred languages. A good understanding of OS internals also helps. I think system-level understanding is where we really is a huge plus for a firmware engineer. And some of the top programming languages are, again, C and C++, though there is a shift in the recent to consider languages like Rust with its focus on safety and concurrency. What difference does firmware make? It's a crucial piece of building a system which is truly manageable and to provide features which are reliable for the system. And it makes a whole lot of difference between whether the system is up or down. If nothing, you can always remotely power cycle the system. Where can you learn more? With open standards and change moving towards this, like Open Compute is one such collaborative unit where four people from the industry are collaborating and sharing hardware standards as well as software. Thank you.
Thank you, Chitkala. Very impressive. I don't think I've seen anyone do 12 slides without taking a breath before. That was amazing. All right.
Yeah, so last year I attended my first SREcon, and guess what happened? I met a lot of SREs. So I realized that they are a lot of interesting people, and I had a lot of interesting conversations with a lot of SREs. So I thought I'll just record all of their stories and run it as a newsletter so that everyone can get to know about these people and get to learn from them. So I started a newsletter. Everybody was running a podcast or a videos. So I thought a published format might be a better approach. So this newsletter is SRE Stories, where I talk with SRE people and ask them questions about their work. How do they go about interacting with other people? How do they go about their day? And how do they use, what tools they use, what are their ways of working with other people, and so on. Another interesting point that I ask is about how they like to be not communicated, as well as how they like to be communicated, because a lot of our working ways have changed over the last few years. So it's important to understand how people communicate as well. Another interesting question that I ask is, how do I become a good SRE? Because what I realized is that a lot of people have different backgrounds and perspectives about what their work style is, and they have a lot of insights about how someone can get started as an SRE, as a junior SRE, and how they can become better SREs over their career. So that is also one question that I ask. And a lot of other cool stuff, like do they use any like different tools, softwares, like do they use multiple monitors, whatever their setup is. So a lot of other cool stuff as well. So stats so far, I have published around 14 stories, thanks to all the people who decided to share their work and stories with me. You can find all of those on srestories.dev. There are a lot of, like, that was the season 1, which was last year after last year's SREcon. Now this is, again, I am here for the SREcon, so the season 2 will start very soon. And the idea is that we'll find some of the people from this audience as well, where they want to share their stories with everyone, so we can publish those. If you think about what are those people who have shared their stories so far, there are around people from 8 countries across the world who have shared their stories from different backgrounds, from different companies like Amazon, Noble9, even Razorpay, and a lot of companies from diverse backgrounds. People have shared their like their entire stories, and some of the points that they mentioned, I would like to highlight there. Maybe you can relate to those as well. Patience is something that they value a lot. And that patience is not just with the tools, but with legacy systems, with other team members, with their work and working with other people. Automation is something that almost everyone said that they do like to automate a lot of repetitive things. So automate was sort of the signal that I got by talking with all of these people. Trust, but without, don't trust without looking at the data. It's something that I understood. People valued looking at signals that they got from all these observability and monitoring systems, and only then take their decisions about how should they respond to incidents. People were very active in community and use community to understand what new things are happening, especially newsletters. Like, I would like to give a shout out to SRE Weekly, our SRE. These are the 2 channels that a lot of people said they get a lot of new information in what's happening with the site reliability world. And the most important point that was again and again discovered in a lot of conversations was that all of us should have empathy about our work and our coworkers. That was the hardest part, that a lot of people said that you can learn everything else, but we have to be kind to other people. So if you want to share your story with other people, like everyone, please schedule time with me. Would love to like publish your SRE story as well.
Thank you, Prathamesh.
All right, SREcon. So, who does blameless retros? Woo! All right, we're going to see what happens when we do that in court. So our story starts in Daly City, just south of San Francisco, beautiful Daly City, California, which has objectively one of the best In-N-Outs in the country because it is co-located with a Krispy Kreme. So you can get your animal-style burgers and donuts and fat and sugar. And so I picked someone up from SFO, and we went to In-N-Out for lunch. And then we took a left turn out of the parking lot there, and it's a bird's eye view, and we were trying to get back on the highway. And so, we're fat and happy on our burgers, and before I know it, I turn around and see my rearview mirror, police officer. By the way, I'm not making this up. It was Officer Directo of the Daly City PD. So he asks, "Did you see the sign? None of this. Do you know what you did? Did you see the sign?" I'm like, "What sign?" And so he's like, "License and registration, please." So he pulls all that, and then 15 minutes later, we were like having burgers, and suddenly I owe the county $238, which put kind of a damper on the mood. So I'm going to be quiet for the next slide, and I want you to see what you can see from this picture. This is the intersection.
There's 2 signs.
I love this.
No,
All right,
no
so
inglés,
yes,
señor.
how many signs did I not obey? And people said there are 2 of them. So I started looking at those 2, and I was like, well, this is kind of weird that there are like 2 there. I guess they really don't want you to turn right. But as I looked at the signs, you'll notice that they're not the same. They have different dimensions. The fonts are different. The spacing is different. And this took me down a really interesting rabbit hole of what should a right turn sign look like. which you can answer by looking at the California Manual on Uniform Traffic Control Devices. And I spent 20 hours of my life trying to figure this out, and it turns out that sign has not been street legal in the state of California for 15 years. Okay, that's interesting. Yes, right turn only, but where? You'll notice there's arrows into that parking lot that has the right turn only sign. By the way, this is the DMV, the Daly City DMV. So, yes. Well, so here's the thing. It's like maybe that's it applies to the DMV. Who owns sign maintenance? So the picture on the left I took the day of. The picture on the right is 6 months later. You can see the sign is even more obscured than it was previously. So who owns the sign maintenance there? And finally, the street markings are all over the place. I love this arrow. It's like, go straight. Somebody did a turn left, and then somebody's like, no, go straight. There's no double yellow line in the middle of the street. So I don't know what's going on there. But these markings are somewhat confusing. So what can we learn here? In the context of an incident, especially when you arrive on scene, the situation is not always what it appears to be. The officer and I had very different parsings of what was going on, and neither of them was entirely correct. Next takeaway. When conducting an incident analysis, the proximity of your investigation to the actual incident matters. If I had not returned later that day to take photos, I wouldn't have been able to gather evidence so that I could look at the situation calmly, but also look later at what happened. And finally, Dr. Decker, remember the chart of the new view. You want to understand why it made sense for people to do what they did, because if it made sense to them, it will probably make sense to other practitioners too. And I saw numerous drivers turning left out of that intersection on subsequent visits to In-N-Out. So, would the court entertain this new view, this blame-aware, blameless view? The judge said, I'm going to take this case under advisement. It was the only case she did that for, and I was like, I don't know what that means. Is that good? Am I screwed? I don't know. Well, boom. Not guilty. So, friends, practice those incident analysis skills because you never know where they're going to come up handy. My name's Paul Reed. That's all I got.
Excellent. Thank you, Paul. And new rule, no more talks that have pictures of food in them, because I'm really not going to make it if we keep doing that. All right,
Hello,
Ted.
my name is Ted Hahn, and I am here to ask and answer a very simple question that is not simple at all. Chrome now supports name constraints and trust anchors. What does that mean? There is one other big piece of information. IANA has proposed the .internal top-level domain as a reserved name, a reserved top-level domain. So you might be asking yourself, what is a trust anchor? It has probably been described to you as an X509 CA certificate. That is usually what people are talking about, but it means a lot more and it means a lot less in the world of security. It can be anything that you trust implicitly. IANA intends to use the .internal domain for internal use, which means that you can now create your own domains and tell your DNS servers to run .internal for your internal services, and this is great. Now that Chrome supports name constraints, you can add name constraints to your X509 certs that you have added to Chrome yourself by group policy, by you touching it. Browsers used to ignore them. Browsers used to ignore them because they were mostly, not designed for browsers, right? X509 certificates added browser support kind of in the 90s, and the original specification was a little bit broken, and then that became specified in the next version of the specification. Up until now, X509 certificates, user-added X509 certificates, have mostly been used for data loss prevention boxes. Don't do that. Don't do that anymore. But it's finally safe to do so now. And it's finally safe to do so now in Chrome, in Golang, in Java, in Python. All of your favorite libraries, including OpenSSL, finally have support for using the name constraints that are on the CAs, the trust anchors that you trust. And so you can do that. You might not need to anymore because Let's Encrypt has been around for a while, and you should probably be following the zero trust model where you just mint public certificates for your internal services. But you are using internal certificates, internal CAs, if you are using a service mesh, if you are doing MTLS. You probably have a CA without even knowing it because the service meshes build one for you. So they should have name constraints too on them. That's another great use, and using that, you can add those name constraints and point your users' web browsers directly at your Kubernetes clusters. a modern organization should be using an internal CA, whether it's just for MTLS or whether it's doing stuff fancy with the HSM so that all of their Kubernetes clusters have their own CA intermediates with name constraints for the Kubernetes clusters themselves that all chain back to a root CA that is owned and operated by the company. And that's really why you want to own and operate a CA, is because it's sovereignty. It doesn't require you to have Let's Encrypt. It doesn't require you to go out to someone else and understand what's going on. So the problem is the tooling is kind of bad still. OpenSSL is very fiddly. Your best hope is Cert Manager. Cert Manager has an experimental feature on your Kubernetes cluster. You can just add name constraints and it will mint you the certificate. Great. You should also, when you are minting a certificate with name constraints, poison it. Say that it has a deny name constraint on email addresses. Why? Because you're not issuing email addresses. Nobody issues email address AX509 certificates. So poison it so that you can't. Don't roll your own crypto systems, but this isn't. This goes back 25 years to RFC, whatever it was, that initially proposed AX509 v3. This crypto system is well thought out and well prepared, but finally the tooling has caught up. So thank you and good night.
All right, who's ready for a breathtaking change in tone? I need notes for this, sorry. Oh, you started already?
Did it pause? No.
All right, this is my very first SREcon. Thank you for having me. My name's Cail. I'm really excited to be here. About 3 days ago, I got on a plane from my home in Melbourne and came all the way over here for this conference. Now, quick show of hands. Anyone else fly here? Drove? Public transit? Awesome. Walk? Anyone walk here? Yes! Amazing. Thank you. I'd like to do a thought experiment about ways that we could improve reliability. Don't worry, that's all going to come relevant later. We've all been there. Some highly paid person whose opinion really matters comes to you, grasping the AWS S3 documentation and asking you, Cail, they've got 11 nines. Why can't I have 11 nines? You keep saying we can only afford 3. Make it work. What on earth are you going to do? Now, this being SREcon, yeah, I know it's... I've been told it's mandatory to refer to 2 concepts. So, first, you could spend huge amounts of time and money on... Pause for slide transition. Dickerson's hierarchy of reliability. Build yourself a world-class team able to handle everything that gets thrown at you. And no doubt this is part of how AWS does that, for real. But if that's not enough, you could invest in doing some socio-technical work using Rasmussen Safety Triangle or FISH. Thank you for everyone introducing it earlier today. And find out just where you are relative to that error margin on the right-hand side there. You could do all of that, but that costs money. And we don't have money. And this highly paid person, they don't want to spend money, they just want nines. They're not going to entertain anything more complicated than like ticking a little HA box on a cloud database. So what if there was a way you could avoid all that and just buy some reliability? So I'd like to introduce service level offsets, or SLOs, which I think that acronym's free, right? Here's how it works. You give me money. Not 11 nines money, but just a little bit of money. And in return, I give you a certificate that says, I'm going to reduce the reliability of some hypothetical future service and give it to you now. And you can take that certificate and give it to your manager, and you have a whole bunch more nines. I mean, job done, right?
How are you making these slides available online?
If all this sounds strangely familiar, that's because I modeled this on the way carbon offsets work. So let's say, for example, pause for slide transition. Oh, no, I'm really early. Well, let's say you wanted to offset the emissions caused by, I don't know, flying from Australia to America. All you have to do is when you book your ticket, as part of the checkout process, I don't know if you've done this recently, traveled internationally, you can just give someone $59. What emissions, right? Who cares? It's fine. Don't worry about it. Here's the problem. Thought experiment over. Carbon offsets don't work. because you're emitting now, but you're paying someone to maybe do something later. But damage is being done now. I mean, doing something later doesn't help you. So I see our reliability challenges as kind of similar. There's no way to just buy reliability now. You have to do the work to understand the context you're in and improve things there. And I'd say be very careful about vendors coming to you, third parties coming to you saying, oh, just buy our solution, it'll make you more reliable. Be very wary of AI telling you these things. They're probably trying to do the equivalent of selling you a certificate. And finally, think about your transport emissions when you travel. It's not something you can buy your way out of either. Thank you so much for your time.
Hi guys, I'm Tushar, and today I'm going to cover another Kubernetes feature looking for a problem. Today I'm just going to cover challenges in on-prem Kubernetes and how BGP addresses those issues, as well as best practices and some potential concerns that comes with this type of design. Okay. In an on-prem environment, the infrastructure should be robust, scalable, and efficient to handle dynamic workloads. BGP achieves this by responding to network changes and facilitating dynamic routing for stable and efficient communication. While Kubernetes aims to address challenges related to traffic management, in an on-prem environment, it is constrained by limited hardware resources and finite physical infrastructure. When you use BGP, you can achieve n-way active-active load balancing, and that would allow you to use standard router hardware instead of bespoke load balancers. This allows for fast failover, as well as more efficient use of available bandwidth. How do you do that? You can abstract the implementation to a CNI, such as Calico, to advertise your prefixes or a single IP, or use Metal LB for stateless load balancing. Let us trace the path of a packet in a BGP data plane. A packet from the internet would go to one of the nodes through a cluster IP, and that cluster IP is learned via the use of BGP advertisement. The kube proxy on that node would then redirect the packet to the right pod using network address translation. That might be the same node or might be a different, which would result in another hop. Okay, couple of peering strategies. You can peer directly with the Tor switch, and that would allow you to exchange routing information through the Tor switches directly. You can also use a route reflector if you have a large number of nodes, something like greater than 100. This is the AS per rack model, where your autonomous system is confined to a rack. In this case, the Tor switches are mainly responsible for exchanging routing information. And this is the AS cluster model, in which your autonomous system is confined to each cluster. This allows for easier to scale and maintain architecture, especially if you have a VXLAN-based fabric. One should also use ECMP to maintain continuous service availability, but it should have a deterministic hash behavior. This will allow parts of your network to fail without causing a complete outage. Now, data center also needs to manage how they adapt to dynamic workloads as network traffic increases. Again, use network-provided tools such as Anycast or ECMP to allow for dynamic scaling. Some best practices: you can use BFD for directly connected peers, implement BGP graceful restart, and add path to have support for multiple next hops, and use route refresh capability to allow for routing updates without causing a downtime. Some failover strategies: you should also ensure that your node peers with multiple top-of-the-rack switches, and you can also use K8's network policy to steer the traffic. As you all know, there is no free lunch in engineering. While BGP has its pros, the stateless nature of the protocol does not adapt swiftly to backend changes. This can cause bursts of reset connections to the client. Just something to keep in mind. That's all from my end. I'll be here today and tomorrow at the conference if you want to talk more about it. Cheers.
Thank you.
Thanks. Hello, everyone. I am Adam. I'm glad that you're all here tonight to listen to this bullshit. This lightning talk is about something that's been annoying me for a long time since I was an SRE at Google. In 2012 or so, this guy, cringe nerdcore rapper Caputo the Python, said that there are two sides to being ill: rapping and also raps. And I want to clarify that I don't know anything about that. It's just the best I could do. And it struck with me at the time because performing raps, as in rapping, and actually writing them, like on your rhyme book or whatever, is two very different professions. And I felt at the time that there was a very good analogy to dev and SRE. At the time, devs were working away, doing their work, building systems, and I was deploying them. Now, there are some people, like Tay here, who can do both of those things. They can write their own music, and then they can perform it on stage, and they're amazing. However, most of us are incapable of doing that, including me. This guy here, this is apparently, it's a bad slide because this guy can do both as well. This is Jack Antonoff. He's a famous songwriter, but you've probably never seen him. You're probably not familiar with him because he's not like up on stage gyrating in sequence and all of that. What he's doing behind the scenes is making bank writing music. This is me right here, the operations guy. I don't know if you knew this, but Elvis never wrote any of his own fucking songs. They were all written by somebody else behind the scenes. What he was doing was just up on stage, sequence, gyrating, same template, and he was doing it world class. He's ops. And so what I'm saying here is that there are actually two separate professions. DevOps is actually writing the software. Dev, very important stuff. You'll note that it's very short. I don't really know what devs do, to be honest. And then, and then there's ops, which is me, and I'm running it. And so one of the things that inspired this was this book. I meant to get a picture of the original SRE book. This is the second one. Doesn't really matter. This annoyed me because this book is all about DevOps. This is not actually about SRE. And I don't have time to talk about it more. So what happens in practice when you do DevOps is you've got a bunch of services here. This is in production, and this is how everyone seems to do it. You've got 4 services. You've got 4 dev teams. The dev teams do the dev. They do the ops. But the ops on each of these services, what I've noticed over the years is the ops is actually pretty similar. Like the bit that sits above the waterline there, it's pretty different. It's what makes the service unique. It's the functionality of the service. But then there's all this bullshit underneath. It's like YAML engineering, and it's like, how do you work Kubernetes? And it's like incident management and all of that. If you take those blocks out of the bottom of each of those services, the stuff that everyone's doing the same, you've actually got one, it's another box at the bottom there. It's the ops, it's the incident management, it's the YAML engineering. And so if you take that into a separate team, you might call that team the reliability engineering team, I don't know. They're doing the same thing 4 times. 4 services is 4 copies of exactly the same thing. You can actually scale that. Unlike making every engineer do the same work, you can take, I'm going too slow. You can do more of that using the same resources, or you can squash it and have fewer headcount. I know that sounds a lot like sysadmins. When the devs, they write the software and then they throw the software over the wall and then like somebody else runs it. But my claim here is that it's actually not like that at all. Over the years, like we've always had sysadmins, we always will. Like back in the day, we had these guys who were like plugging in the replacement tubes because the old one blew up. And now we have these guys who are plugging in like new blades. Like obviously we're always going to need actual sysops. But what we've been doing over the years is we've been raising the water level. Like we've been taking all of the stuff that everybody needs to do, all of the scaling, the VMs, the like managed services and the managed databases and all of that. We've been letting devs build more stuff on top of that. When I think about SRE, and what like I used to do as like an actual SRE, not like a DevOps person, is that I was also trying to raise the water level. I was trying to take away a lot of the stuff that devs used to have to worry about in the same way that managed services do, like the SLOs and all the other stuff, and I was taking that off their plate so they could focus on the things which are actually interesting. And so my claim here is that SRE is actually an alternate universe version of managed services that we all rely upon, which is, I'm out of time, but I'm right. Thank you.
Tonight, on a very special episode of SREcon Lightning Talks,
that nobody asked for. All right, so a little over a year ago, ChatGPT, yes, that's how it's pronounced, broke onto the scene with an immediate and predictable response across the entire industry. Specifically, a whole bunch of companies we've all heard of lost their goddamn minds and started talking about literally nothing else, including GitHub deciding to refound the company around Gen AI, which is a totally normal and not at all ridiculous thing or disturbing thing to hear from the company that you trust with all of your IP. Now, developers were super excited about this until somewhat recently when they realized, oh wait, maybe I'm not unique. Maybe the tide is rising and that's going to be a problem for me personally, and they're starting reverse course. I've already been there. Why? Because I am a mediocre white guy and I am the single biggest under threat target for generative AI. In fact, I'm so mediocre, you might not have noticed yet, that's not actually me. We are interchangeable. We're like containers. I'm serious. I run 2 podcasts. I believe that ketchup is dangerously spicy. Let's be clear here. And almost everything out of my mouth is pure, unmitigated bullshit, in case you hadn't somehow caught up on that. But the problem here is that the world runs on bullshit. You don't need an in-depth understanding of things. All you have to say, as a mediocre white guy, is anything confidently, and even if it doesn't stand up to scrutiny, people will take it at face value. Now, it's getting dangerously close for me because all of these things are the things that I do that AI is slowly but surely taking away from me, including most notably that last item of making AWS look completely ridiculous. The problem here is not that I'm worried about it taking my job. No, the problem here is that I'm jealous because I want what AI has. What does it have other than a whole bunch of budget thrown at it, which I also want? The ability to speak on behalf of companies. That's right. That is how AWS marketing speaks, misspellings and all. Only authorized speaking may speak of the company. They wish they could stop me. I want to do that. I do that, I get yelled at. This is the USENIX Code of Conduct, which is excellent, and I put that up there instead of what I got the Gen AI robot they put on a product webpage to say. It made a dirty limerick about a product that adults use to pleasure themselves. That's right, Amazon sells Kubernetes. Now, I understand that this might not be the most sympathetic show person for this because, let's face it, a lot of things come for me as a typical mediocre white guy, and we as a demographic are not particularly sympathetic. But I'm here to warn you because eventually it comes for all of us as all of these systems start looking into what data they can get their hands on. And, of course, Microsoft has all the GitHub stuff. Google has basically everything because they're Google. But what does that leave Amazon with? Unfortunately, all they've got is magic microphones in everyone's rooms that they can listen to whatever happens in those rooms, and they recently bought my doctor's office, which is kind of a problem for me. If I wanted to talk in depth about my schmeckle with Amazon employees, I'd become one of their worst engineering managers, but that's sort of beside the point. Now, we can't do much about this because we can't stop the clock. We can't stuff the genie back in because he will throw hands back at us. That's what he does. Progress marches on. So what are we supposed to do about this? Well, we can embrace it for one. My daughter told me to send her a happy, screamy unicorn, and we made it progressively happier and screamier. And we had an awful lot of fun with it. And I think in there lies the secret, which is that all of these companies are getting into this stuff. Like, look at the IBM clown cart. Even they're getting in on this. And it's a clown cart because they haven't quite figured out the internal combustion engine yet because they're a little bit stuck in the past, but that's okay. They're going to hate this joke when I wind up telling it, in 3 years. But ultimately, the trick is fundamentally that these companies do not have a sense of humor, despite the fact that this stuff is objectively funny. And yeah, I'm well over, a sense of humor. That's Amazon PR spelling. We covered that. That's the world. That's what we live in. And now we're dealing with slide karaoke. Yes, that's how it's pronounced. Thank you for tolerating me.